When you put an artificial intelligence in charge of critical national infrastructure, like a multi-billion-dollar power grid, the stakes are absolute. A single unverified decision can trigger cascading physical failures. Currently, the industry attempts to protect these opaque black box models with software firewalls and passwords. But software alone is vulnerable. Any system permanently connected to the internet carries the inherent risk of being breached. This creates a dangerous paradox. If you keep the AI offline, operators can't monitor it. But if you connect it to the internet to verify its decisions, you expose the proprietary mathematical parameters and root alignments that make the system function to extraction and theft. Software-based trust is simply too fragile for civilization-scale systems. To guarantee security, we need a hard physical boundary between the engine that creates the intelligence and the network that delivers it. To solve this, UnityGrid built an asymmetric two-machine topology. We divide the architecture at the hardware level. On one side, you have the brain that invents the solutions. On the other side, you have the gateway that communicates those solutions to the outside world. This division is designed to keep core logic hidden while providing a dedicated surface for auditing the results. It is the first step toward verifying an AI's behavior without ever needing to see its source code. We call the brain the iron core. This is a localized workstation where raw intelligence is generated using complex 248-dimensional mathematical modeling. It operates under absolute physical constraints. It runs entirely on its own internal CPUs, and it is strictly air-gapped. There is no Wi-Fi, no Bluetooth, and no Ethernet cable connecting it to the outside world. It crunches massive logistical problems and grid simulations, but its underlying logic and the raw data it processes are permanently trapped inside the machine. Because there is zero outward network exposure, it is physically impossible for hackers to contaminate the source of the intelligence. To pull those answers out safely, we use a secondary machine acting as the gateway. This machine connects to the internet, but it holds zero proprietary secrets. The connection between them is highly restricted. The gateway only possesses a strict read-only window into the workstation's outputs. It can observe the workstation's answers and write local cryptographic receipts to prove what it saw, but it lacks the physical permissions to send a single byte of data back to the core. The gateway serves as an independent auditor. It verifies the truth of the decisions, but physically cannot corrupt its source. Let's track a high-stakes decision, like routing a surge in power as it travels from the isolated workstation across that read-only bridge and toward the gateway. Before it reaches the outside world, the gateway executes a process called antimicrobial redaction. It aggressively strips away the proprietary intellectual property, the internal algorithms, and the neural weights. What survives this process is the redacted sovereign knot, a clean, cryptographically sealed summary of the decision. This gives the grid operator ironclad mathematical proof that the AI's calculation was healthy and accurate, without revealing the proprietary code that made it. This stripping mechanism forms the epistemic data wall. It takes raw, secret intelligence and transforms it into safe, publicly verifiable truth. Imagine a worst-case scenario. A sophisticated adversary completely breaches the outward-facing gateway laptop. The attack instantly dies at the bridge. Because the connection is read-only, the gateway physically cannot write commands back to the iron core. The adversary might manage to steal the redacted receipts, but the underlying mathematical logic remains perfectly insulated. The epistemic data wall creates an unbreakable physical barrier, ensuring that even a total compromise of the network cannot touch the intelligence governing the infrastructure. With mathematical certainty, UnityGrid never asks a sovereign client to blindly trust hidden code. We have shifted the burden of trust away from inspecting vulnerable source code, moving it entirely to verifying cryptographic outcomes. Now that we know exactly how this intelligence is physically protected, what happens when we plug it directly into a national power grid?